Have you ever wondered how JavaScript handles asynchronous operations inside loops? It can be a bit tricky, right? If you're curious about whether using await inside a loop blocks the loop, you're in the right place. Today, we're diving into this topic and clearing up the confusion. I totally get it. Many developers have faced this question, especially when dealing with slow asynchronous functions. It can be frustrating to not know how your code will behave. You're definitely not alone in this. Let's look at the specific question at hand. One user asked, does using await inside a loop block the loop? And is the order of operations guaranteed? If you've ever found yourself in a similar situation, stick around as we explore this together. So, what happens when you use await inside a loop? When you await a promise, the execution of that loop pauses until the promise resolves. This means that the loop does not continue to the next iteration until the current one is complete. Let's break this down further. And don't go anywhere. At the end of this video, I have a great tip that will help you manage asynchronous op more effectively in your JavaScript code. To answer the user's question, we first need to clarify how the await keyword works inside a loop. When the user uses await in a loop, it does indeed block the loop until the awaited promise is resolved. This means that the variable I does not continue to increment while waiting. Instead, the loop pauses at each iteration until the asynchronous function completes. Next, let's discuss the order of execution. The order of the function doSomethingWithResult is guaranteed to be sequential with respect to the variable I. However, if the awaited function takes varying amounts of time to resolve, the overall time taken for the loop will depend on the slowest iteration. In summary, using await inside a loop blocks the loop, and the order of execution is sequential. The user should be aware of the potential delays caused by the asynchronous function's execution time. Fun fact, did you know that JavaScript was created in just 10 days? It's amazing how far it has come since then, but understanding its quirks, like async behavior, can still be a challenge. Now let's look at the answers provided by other users. This user explains that using await does not block the event loop. They provide an example with two functions. The first function, awaitGo, waits for a promise to resolve before continuing, while the second function, notawaitGo, does not wait. Both functions demonstrate that the event loop remains unblocked, allowing other tasks to run. Now, let's dive into a different answer from another user. This user explains that using await inside a loop does block the running function until the async operation completes. However, the JavaScript engine can still handle other tasks during this wait. They also highlight that the loop will execute sequentially, ensuring that each iteration waits for the previous one to finish. They provide an example showing that you can start the async function without await, allowing other operations to run before waiting for the result. This approach can improve performance in certain scenarios. That wraps up that answer. Let's move on to another one. This user provides an interesting test solution to the question. They demonstrate that while using await inside a set timeout callback does block execution, the set interval continues to run. This shows that the event loop remains active, allowing other asynchronous tasks to execute. That wraps up that answer. Let's move on to another one. This user clarifies that using await inside a loop does block the loop. The doSomethingWithResult function will only execute after the await finishes its task. They explain that promises run before the next event loop cycle, meaning that if you have long tasks, it can stall the UI. To avoid this, they suggest using web workers or inserting pauses with set timeout. That wraps up that answer. Let's move on to another one. This user clarifies that using await inside a loop does not block the loop. The loop continues to increment the variable I while awaiting the asynchronous function. They also explain that the order of the results from doSomethingWithResult is guaranteed to be sequential, but not in relation to I. It depends on how quickly the awaited function completes. The user provides an example to illustrate this. In their code, all console logs for the API calls are printed first, followed by the results after all calls have executed. In conclusion, they emphasize that using await in a for loop does not guarantee immediate processing of results, as these may take time to finish. They suggest using the neo-async library for better handling in Node. Here's the tip I promised. When working with asynchronous functions in loops, consider restructuring your code to use arrays and promise.all. This can significantly improve performance and make your code cleaner. And there you have it. Now you know how await works inside loops in JavaScript. Remember, understanding these concepts can greatly enhance your coding skills. If you found this video helpful, please subscribe for more tips and tricks.